Who are our most avid customers? Let's find out. Welcome to this video on analyzing business data with T SQL. My name is Kevin Fiesel, and I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. Over the course of this series, we have looked at a variety of measurements that retailers can use as key performance indicators. We have reviewed financial KPIs, customer-centric KPIs, and sales KPIs so far. Today, we are going to focus on the concept of avidity. Avidity is just a fancy term for who are our biggest fans. In the sports world, these are the people out there tailgating in sub-freezing temperatures 5 hours before the game starts, because where else would you rather be than right here, right now? But in the retail world, we don't often have people camped out in front of our stores waiting for them to open. Or if we do, it's because there's a massive sale going on, not because these are super fans of our retail chain. Instead, we are going to need to come up with a better approach. Let's go to the demo and see what we've got. Here we are one more time in Azure Data Studio. I am down to the final 2 key performance indicators in this series, and one useful T SQL concept we haven't really touched upon yet. What I would like to do is answer the question, who were our top customers for August of 2015? There are a few ways of defining what a top customer is. We could look at the number of orders, the total sales amount, or even the profitability of these customers. We could even think about top customers in terms of regularity, making orders month in and month out. In this video, I'll focus on the number of orders and sales amount just to keep things simple. First, let's look at this question from the standpoint of number of orders. Who are our top 10 customers in August of 2015 based on the number of orders made that month? To find the solution, we can start with some of the analytic techniques we have discussed in prior videos. We'll begin with a common table expression, customer results. Inside of this CTE, we join the orders table to our calendar table to make it easier to aggregate data by month, especially if you are not on SQL Server 2022 or later and can take advantage of the date trunk function. In our base query, we drive from the customer results virtual table, joining once again to sales.customers. The reason we need to make this separate join is that I am grouping by customer ID, but I also need to get the customer name, so we'll do that down here. Finally, I'll order the results by number of orders descending so that we get the largest number of orders at the top, and I'll slap on a top 10 to get only the top 10 customers. Let's give this query a run and we can see something interesting. All of our top customers had either 7 or 8 orders this month. We had 6 customers with 8 orders and 4 customers with 7 orders. But that leads to a follow-up question. Were these the only 4 customers that had 7 orders? Because if not, we arbitrarily cut off top customers and there exist other customers with the same number of orders as these. Well, we can easily modify this query to answer that follow-up question. I'll start with the same common table expression, except this time I'll use the having clause to show me only customers with at least 7 orders in the month of August 2015. Then in the base query, I'll remove the top 10 in order to get back all of our customers. And when I run this query, we can see that there are a total of 16 customers with at least 7 orders in August. Why is this relevant? Well, let's suppose I wanted to provide a small incentive to the top customers, maybe a coupon off of their next order. If I limited the results to the top 10, there would be 6 customers who could be eligible for the coupon, but due to the arbitrary mechanism I put in place to find the top customers, we would not see them. We might thus lose out on an additional sale from some of these high-frequency customers. Well, in that case, what can I do about this? For this simple question, I can slap on with ties to my top operator. This will include the top 10 results, but it will also include anything tied with 10th place. Running this query, we get back 16 results, which is what I expect to see. As an alternative approach that can handle additional levels of complexity that top with ties cannot, here's where another type of window function comes into play, ranking window functions. There are 4 ranking window functions, and all of them have been available in the T SQL language since SQL Server 2005. They are row number, rank, dense rank, and the slightly weird cousin, intile. For today's video, I am going to focus on the first 3. Let me give you a quick primer on ranking window functions, as these are different from aggregate window functions like sum and average, as well as offset window functions like lag and lead. I'll start with row number because that's typically the one DBAs are most familiar with. Row number generates a monotonically increasing natural number for each row in the window. In other words, row number starts at 1, always increases by 1, is guaranteed never to duplicate a value within the context of our window, and resets to 1 when we switch to a new window. Row number is going to require an order by clause, as that is the only way we can appropriately rank things. In this first query, we have the date and want to generate a row number ordered by date. If I run this, we can see our monotonically increasing series. We can also see that I've sorted the entire result set by date and have also ordered the row number function by date, but this is not required. In fact, let's order the result set by something wildly different. I'll say the combination of day of week and fiscal week of the year. This time, if I run the query, I get row numbers that are in no relevant order. But I'm still guaranteed to have exactly one record with a row number of 182, one record with a row number of 2373, and so on. We can also break things out into window partitions using the partition by clause inside of the over clause. This time around, I'm going to partition by the day name and order by the date. I will also limit my results to January of 1901 so that we don't have too much chaos, just a limited amount of chaos. Running this query, we can see for each day name that row num starts at 1 and increases as we move on throughout the month. There were 4 Fridays in January of 1901. Then, when we switch our window to look at Mondays, we reset our row number and start again with January 7th being the first Monday in that January. With that primer on ranking functions out of the way, let's look at the data from August of 2015 and see how this helps us. I'll start off the customer results common table expression the same way that I have before. Then in my main query, I'll include a row number, sorting by number of orders descending. That way I can track our best customers. Running this query, we end up with exactly what we would expect, a monotonically increasing value for each customer based on the number of orders in the month of August 2015. The problem, however, is that we had 6 customers tie with 8 orders, yet we are arbitrarily assigning different rankings. Does the customer in 6th place really deserve different treatment from the customer in 1st place? Probably not, given that we never introduced the idea of tiebreakers, just sheer number of orders. For this reason, row number may not always be the best choice of ranking function. It's fantastic if we want to have this kind of unique ordering, but this is one scenario in which that might not make as much sense. Instead, let's take a look at the other 2 ranking functions, rank and dense rank. These two behave very similarly in that they will treat ties as ties. The difference between the two is how we handle what happens after a tie. The rank function shows ties like you would in a race or a competitive standing. The way you can describe rank is, my rank is the number of people who were ahead of me plus myself. In other words, let's say that 2 racers tie for 1st place, and we have 3 other racers who followed behind. The first 2 have 0 people ahead of them, so 0 plus self equals 1. The next racer had that tied pair ahead of him, so 2 plus 1 is 3, and so on. Dense rank, meanwhile, looks at levels of results. All ties are on the same level, and then we move to the next available natural number. Using the same scenario as before, we have a tie for 1st place. Those 2 people are both on level 1. The next person who finishes is on level 2, and so on. That's why we call it a dense ranking. We don't skip natural numbers like we do with competitive ranking. Let's see all 3 of these in action. To do so, I will start once again with the same common table expression. Then we will layer on row number, rank, and dense rank in the base query. All 3 of these include our necessary order by clause, and we have no partition by clause, as we do not want to split out our customers by something like, say, sales territory. When I run this query, we can see our results. For the 597 customers with orders in August of 2015, our row number gives us a monotonically increasing natural number, which we've already decided is not great for this scenario. The rank function shows a 6-way tie for 1st place, followed by a 10-way tie for 7th place, and then we continue on to 17th place for those customers with 6 orders. The dense rank function results show these instead as level 1, level 2, level 3, and so on. Looking at how all 3 of these work, we can come up with a fair way of sending coupons to our top customers. I'll start with the customer results common table expression. Then I'll include a second common table expression with ranking data. Admittedly, I just need the rank function here, but I'm keeping all three for display purposes. Also, I need to wrap this in a common table expression or a subquery because I cannot reference window functions in the where clause. Finally, in my base query, I can select anything from my rankings virtual table where the rank is 10 or below. This captures all 16 of my top customers for the month, just as we want to see. And that was capturing customers by month. Now let's look at the final script and think about a different way of handling customer avidity. This time, we will look at recent sales for customers and see which customers are our biggest spenders based on their recent behavior. One great way of doing this is to use the apply operator. We talked about apply in the prior video, specifying that allows us to execute an ad hoc function for each row on the left-hand side of a query. For this first query, we are going to get the 5 latest orders per customer. We start with the customers table. Then, for each customer, we call cross apply and retrieve the top 5 orders, sorted by order date descending. That way, we get just the latest orders. After that, we have another cross apply operation. This time, we are querying order lines for each order, getting the sum of quantity times unit price as total revenue. If I run this query, it will take a moment and then return for each of our customers their 5 latest orders. If a given customer does not have 5 orders, we would retrieve however many orders they do have, so this query is robust against customers with fewer than 5 orders. It even works if there are customers with 0 orders. In that case, we simply don't show the customer at all as there are no orders to analyze. This leads to an interesting way of calculating customer avidity: recent average order value. I'll start with the same query base as before, driving from the customers table and then getting the 5 latest orders per customer and the total revenue for each order. Then, in the select clause, I'll show only the top 20 results with ties and include customer ID, customer name, and the average order value. Because I have an average function call in the select clause and I have non-aggregated columns, I will need a group by clause that includes my non-aggregated columns. And then I'll be able to sort by average order value. Running this query, we can see that I get 20 results back. I did include the with ties just in case, but because we're dealing with decimal values over a fairly wide range, the likelihood that we would actually have a tie in the 20th position is pretty low. Nonetheless, we can see our top customers averaged just over $5,000 per recent order, and 20th place is just over $4,000 per order. That is going to do it for this series on analyzing business data with T SQL. We covered more than a dozen measurements that retailers typically convert into key performance indicators. And along the way, we learned about a variety of analytic techniques in T SQL to make these calculations possible, even if you do not have a well-specified data warehouse that does most of the work for you. We'll have links and show notes in the description below. And until we see each other in the next video, take care.